Hi, my name is George Krumins. This assignment is for Technology and Society, EIU 4102G. My subject is killer asteroids. How is technology protecting civilization from total destruction? For over 40 years, telescopes have been seeking out killer asteroids, or as astronomers call them, NEOs, or near-Earth objects. Many are familiar with the scientific theory that the dinosaurs faced extinction when a killer asteroid smashed into the Earth millions of years ago. This asteroid was estimated to be 80 kilometers or 50 miles wide, and when this huge asteroid entered our atmosphere, smashed into the Earth, not only did it kill off the dinosaurs, but the Earth sustained global climate change that may have lasted decades. According to the University of California Museum of Paleontology, this incident caused massive terrestrial disturbance, threw up soot into the air, caused short-term acid rain, emissions of poisonous gases, and cooling similar to a nuclear winter. Long-term consequences would have been a global greenhouse effect, warming, and reduced sunlight. If a large asteroid is discovered headed our way, what could we do to prevent it from hitting the Earth? The key is early discovery. Astronomers use technology to seek out the NEOs, and this includes telescopes with advanced optics, CCD imaging arrays, robotics, artificial intelligence, and, of course, computers. Even at one time, there was an active space telescope that has since failed, but a new replacement, asteroid-seeking space telescope, is currently being worked on. There are a number of ways to prevent a killer asteroid from striking the Earth, nearly all of them including sending a space probe to meet it. If a missile were to be used to destroy the asteroid, it is still possible that significant chunks could impact the Earth. Unlike a dramatic movie using a giant net to capture the asteroid and then using a small booster to attach its net to deflect its orbit just enough to miss Earth might actually be the best solution. Now, if the asteroid was about to smash into the Earth, maybe sending a missile to blow it up might be the only solution. But we have to recognize that if the asteroid just broke in half upon impact with the missile, rather than being destroyed, this could still be catastrophic for the Earth and all of its inhabitants. Of course, this is why early detection is needed. There are a number of observatories searching for NEOs using fast, wide-angle optics. These include the Catalina Sky Survey, Pan-STARRS, Linear, Space Watch, NEOWISE, and the PS1 Consortium. One of the first telescopes used to try to detect these killers was a Schmidt camera, which is a purely photographic instrument. But at this point, there are a number of different types and sizes, some very large, being used to try to seek out these killers. Given the technical challenge of detecting small faint objects, a new project is using the latest technologies of optics, wide-angle digital photography, and computer resources. This project is the LSST, or Large Synoptic Survey Telescope. This is a ground-based telescope. And at the time of its completion, it will have a 3.2 gigapixel camera, the largest astronomical camera in the world. With the joint resources of its optics and camera, LSST will be able to reach these faint objects, map them in three-dimensional space to find out their orbits, and whether they present a danger to Earth. Even though it is probably extremely unlikely that a killer asteroid will strike the Earth within our lifetimes, the magnitude of destruction that would be caused would eclipse anything we have ever experienced. We need to be prepared for such an outcome. And with proper financial support, the important work of seeking these killers out will quietly and diligently be performed by astronomers in observatories and universities worldwide.